Hi everyone, welcome to part 2 of week 2's lab tutorials. Here, we're going to see a few more examples of the tools and techniques we covered in part 1. For this, you need to download the week2_qog.dta file. This dataset is a trimmed version of the QOG dataset, which is published by the Quality of Government or QOG Institute based at the University of Gothenburg in Sweden. This dataset brings together information from almost all countries around the world, covering things like corruption levels, democracy scores, economic development, healthcare access, and government effectiveness. Researchers use this kind of data to ask questions like, does more democracy lead to less corruption? Do wealthier countries have better public service? Is government effectiveness linked to economic growth? The QOG dataset may be one of the sources of data you use in your own research project. This trimmed dataset only has 10 variables, whereas the full dataset has hundreds. Don't worry, the tools and techniques work the same way with both. One important thing to keep in mind, the version of the QOG dataset we are using is cross-sectional, meaning it captures a snapshot of each country at a single point in time, rather than tracking changes over multiple years. So, instead of watching how, say, corruption in Brazil changed from 2000 to 2020, we are comparing many different countries all at once as they looked in that one specific year. This is a really common setup in political science research and is perfect for practicing comparisons across countries, but it does mean we can't make claims about trends over time from this data alone. Let's open the dataset by going to Application, then Open, browsing to where our downloaded dataset is, clicking on it, then clicking Open. The dataset shows as a spreadsheet on the left with the empty results screen on the right. Let's look at the variables. Click on the Variables tab, which loads the name of the variables along with their levels of measurement and description. The first variable is C code, which stands for Correlates of War Code. The Correlates of War project, which publishes several datasets in international relations, gives a numeric code to each country. This makes merging datasets easier. As a result, other IR datasets often also list the Correlates of War code. Next to it is CNAME or country name, which lists the name of the countries. One question you might have is that if countries have names, why assign a numeric code? The simple answer is that a country may have more than one commonly used name. For example, one dataset may have the US listed as United States of America, while another lists it as USA. Similarly, one country may have the DPRK listed as North Korea, while another lists it as Democratic People's Republic of Korea, while yet another lists it as Korea, Democratic People's Republic of. Using a numeric code ensures no errors in merging, as long as you're using a commonly understood numbering scheme. There are other such schemes to identify countries, such as ISO 3. Next is a variable named BCI_BCI. Essentially, it's an index measuring corruption and an alternative to the Corruptions Perception Index we mentioned last week. It's a continuous interval variable. Next is BMR_DEM, which the description lists as being dichotomous. But wait, Jamovi has assigned it as an interval variable. Let's fix that by double-clicking on it and changing the measure type to nominal. This will ensure that we can use the right set of statistical tools on it, since Jamovi wouldn't let you put an interval variable in a place that requires an ordinal variable. Once you turn the variable nominal, you can see the levels 1 and 0. Moving further down, you can see CCP_CC, which is a dummy variable that indicates whether a country has a corruption commission mentioned in their constitution, CPDS_VT, measuring turnout, CSES_SD, measuring satisfaction with democracy, GOL_EST, measuring the type of electoral system, majoritarian, proportional, mixed, etc., HT_colonial, measuring colonial origin, MAD_GDPPC, measuring GDP per capita, UNDP_HDI, measuring Human Development Index, and another GDP measure, this time by the World Bank. Let us bring in a hypothesis to practice cross-tabulation. I hypothesize that countries with colonial history would be less likely to be democracies. My reasoning is that the history of colonialism means that such countries have not had the time to consolidate the kind of institutions necessary for democracy to flourish. How do I test my hypothesis? Let's see what our independent and dependent variables are and their levels of measurement. The independent variable here is colonial history, which is nominal. The dependent variable is democracy. Now, democracy is a concept that can be measured in different ways, such as a simple yes or no, which will make it nominal, as gradations like democracy, hybrid regimes, or autocracy, which is ordinal, or as a continuous score, like the polity score, which is interval. In our dataset, BMR-DEM captures democracy as a dichotomous measure, so it's nominal, which is exactly why we just changed its measure type. Keep this in mind. When you're identifying independent and dependent variables for your own hypothesis, the level of measurement isn't fixed to the concept. It depends on how that concept was actually operationalized in your data. Since we have a dichotomous measure of democracy, here democracy is nominal, so we have two nominal measures, which means we can use cross-tabulation to test our hypothesis. Before we get started, let us look at HT colonial. Instead of just listing whether the country has a colonial history or not, it also lists which colonial powers had colonized it. This is very useful if you have an in-depth research question, but too much detail for us. Luckily, we can create a dummy variable that answers exactly the questions we are asking. Before we do that, let us look at the underlying data in the levels box. It is clear to see that if the underlying value is 0, the country never had colonial history, and if it's anything else, it did have colonial history. Alright, let's proceed with creating the dummy variable. Click on Transform, ensure that HT colonial is the source variable, type in the name of the new variable, say call_history, then create a new transform. Go to Add Recode Condition, and then next to source, type in $=0, then next to use, type in 0. Essentially, it means that if the underlying value of the source variable is 0, which we just mentioned, means that the country doesn't have colonial history, the new variable will take the value 0. Next to else use, type 1. This means that all other countries will have value 1. Hit enter and our new variable is ready. You can go to data and see how the new variable looks and how it's performing. Now that we have our dummy variable, we're ready to do the crosstabs. Go to the Analysis tab and then click on Frequencies. In the drop-down menu that appears, we click on Independent Samples, which is right under where it says Contingency Tables. A new dialog box opens up where you can specify your rows and columns. Drag Call History, our newly created dummy variable, to the columns box and drag BMR-DEM to the rows box. Notice the icon in the rows box. It means that only nominal and ordinal variables will be allowed here, which means that if we had not corrected the measure type of BMR-DEM, we wouldn't have been able to use it here. We have a table of counts for colonial history and democracy. Let's also check columns percentages under cells to make the comparison easier, since we're only comparing proportions, not total numbers. What can you say about our hypothesis from this table? Is there a noticeable difference? I'd say so. The percentages are quite a bit different, but again, we cannot make an inferential claim without running a chi-square test, which we'll cover next week. Let's bring in another hypothesis to practice what we have just learned. I hypothesize that countries with colonial history are less likely to be developed countries compared to those that did not have colonial history. How do I test this? Let's look at our independent and dependent variables and their levels of measurement. The independent variable here is colonial history, which we already have as call history and which is nominal. The dependent variable here is development, which we don't have directly, but we can construct from UNDP_HDI, which measures the Human Development Index. Since UNDP-HDI is a continuous interval variable, we need to turn it into a nominal variable before we can use it in a crosstab, the same way we did with HT colonial earlier. Before we do that, let's look at the underlying data for UNDP_HDI. HDI scores range from 0 to 1, and a commonly used convention is that a country with an HDI of 0.8 or above is considered developed, while anything below is not. So let's use that same cutoff to build our dummy variable. Click on Transform, ensure that UNDP-HDI is the source variable, type in the name of the new variable, say HDI_dev, then create a new transform. Go to Add Recode Condition, and next to source type, type in greater than or equal to sign followed by 0.8. Then, next to use, type in 1. Essentially, this means that if the underlying value of UNDP-HDI is 0.8 or greater or higher, the new variable will take the value 1, indicating that the country is developed. Next to else use, type 0. This means that all other countries, those below the 0.8 threshold, will have value 0, indicating that the country is not developed. Hit enter and our new variable is ready. You can go to data and see how the new variable looks and how it is performing. Now that we have both our variables ready as nominal measures, we're ready to do crosstabs. Go to the Analysis tab and then click on Frequencies. In the drop-down menu that appears, we click on Independent Samples, which is right under where it says Contingency Tables. A new dialog box opens up where you can specify your rows and columns. Drag colhist, a colonial history dummy variable, to the columns box and drag HDI-dev, a new development dummy variable, to the rows box. We have a table of counts for colonial history and development. Let's also check columns percentages under cells to make the comparison easier, since we're only comparing proportions, not total numbers. What can you say about our hypothesis from this table? Is there a noticeable difference? Take a look at the percentages and think about whether they support or challenge our hypothesis. As before, we actually cannot make an inferential claim without running a chi-squared test. Let us move on to means comparison test. We use it when our independent variable is nominal, but the dependent variable is interval. Let me modify my last hypothesis slightly. I hypothesize that countries with colonial history will have lower levels of human development compared to countries without colonial history. Notice that instead of saying developed or developing, I'm saying levels of human development. This means that we cannot directly use the UNDP HDI variable, which is interval. What test do we use when our independent variable is nominal and the dependent variable is interval? That's right, it's the means comparison test. We would be comparing the means of HDI for the two groups, those who have colonial history and those who don't. Go to the Analysis tab, click on Exploration, then select Descriptives. This is where we can do a means comparison by splitting the data into groups. To do this, first put the interval variable, which in this case is UNDP HDI, into the variables box. Then we'll put the nominal variable, which is call history, into the split by box. Essentially, it will give us the same summary statistic, but this time for the specific groups. Do you see a noticeable difference between the means of the two groups? Let us test another hypothesis. I hypothesize that countries that have a corruption commission mentioned in the constitution will have less corruption compared to those without. What are our independent and dependent variables? The independent variable here is CCPCC, while the dependent variable here is BCI. The former is nominal, while the later is interval. We do the same thing we did before, putting the interval variable in the variables box and the nominal in the split by box. Do you see a noticeable difference between the two? In both of these tests, just because there is a difference doesn't mean that it is statistically significant, and we cannot determine that without running a t-test, which will be covered next week. Let us make some graphs. As before, the graphs we will be using will depend on what we want to visualize. Let us form some single variable graphs first. Go to the Analysis tab, click Exploration, then Descriptives. Now move BMR-DEM into the variables box. Click on Expand Plots and check bar plot. We have a bar chart showing the number of democracies versus non-democracies. For an interval level variable like UNDP HDI, we can use a histogram to look at its distribution. Move the UNDP HDI variable into the variables box and check histogram. Unlike the bar chart, a histogram groups continuous values into bins, and the bars touch each other because the underlying variable is continuous, not categorical. This lets us see the shape of the distribution. We can also create a density plot to show this same data. Simply check density. Finally, let's create a box plot. Move the variable MAD GDPPC into the variables box and check box plot. You can see the interquartile range in the box in the middle, as well as the outliers. Does this variable have a lot of outliers? What does that tell you about this variable? Where do most of the outliers lie? Let us now create some graphs to show the relationship between variables. Remember the hypothesis we tested about colonial history and democracy? Let us see the relationship graphically. We go back to where we ran our crosstabs and put the variables into the appropriate boxes. As before, the cross-tabulation table is generated. To generate the stacked bar chart, click on the Plots ribbon and check Bar Plot. To make sure that the x-axis is set to columns, since that is where we put our independent variable. The y-axis should be percentages rather than counts, and the box next to it should be set to within columns. Also, check the stacked option to make it easy to visually compare the proportions. Look at the plot. To read a relationship from this graph, compare the segment proportions across the bars. Can you tell if there is a noticeable difference? I'd certainly say so. We can also test our other hypothesis about colonial history and developed countries by moving the correct variables into the suitable boxes. The stacked bar chart instantly forms, provided you didn't change any of the other settings. Now, if our independent variable is categorical while the dependent variable is interval, we create a bar chart of means. We go back to our hypothesis about colonial history and levels of development. Go back to where you did your means comparison and put the appropriate variables in the correct boxes. We see their respective means. Now, go to plots and check the bar plot option. Here, each bar's height represents the average value of HDI for both groups, those with colonial history and those without. To read the relationship, compare bar heights across groups. A big gap between the tallest and the shortest bar suggests that colonial history may be associated with differences in levels of development. The brackets you see on top of the bars are confidence intervals, which will be discussed next week. Finally, what happens when both the independent and dependent variables are interval? Let us check to see if corruption has an effect on human development. Go to the Analysis tab, click on Exploration, and select Scatterplot. Put BCI in the independent variables box and UNDP HDI in the dependent variable. Jamovi will create a scatterplot on the right. Here, each point represents one country positioned by their corruption index score and HDI. Three things are immediately clear. First, the relationship is linear, since you can draw an imaginary straight line through the cloud of points. Secondly, the direction is negative, since the imaginary line is downward sloping. This means that corruption is negatively associated with human development. You can see this clearer by clicking on linear on the regression line option and making the imaginary line real. Lastly, the points are more or less tightly concentrated, which probably means that the effect is statistically significant, although we cannot determine that conclusively without running a bivariate regression. This brings us to the end of part 2 of this week's tutorial. Make sure to save this file as a Jamovi file so you retain the new dummy variables created as well as the analysis you ran. I would encourage you to form some of your own hypotheses, determine what variables will be needed to test them, create any necessary dummy variables, then run the necessary tests and create the appropriate graphs and charts. The more you practice, the better you'll get at this. You can also download the full QOG dataset and go through it and practice those skills there. The dataset will be linked on Canvas. Thank you so much.